Everyone, we are going to move into lesson 2 here, looking at congruent triangles. Still, we're going to apply congruence in triangles, but this really extends to any shape and how you can use congruent figures to solve problems by looking at their congruent parts. So congruent, if you remember from your proofs, it means same. So congruent figures have the same angle measures and the same side lengths. Another way to think of it is they are the same size and the same shape. Okay, they have to be identical. Now, that doesn't mean they can't be like this, where they're like reflected, but this is what we call a congruent statement. And we can learn a lot from the congruent statement because the order of this will matter. A congruent statement tells us like A and Q, this angle and this angle are congruent. B and R, so B is congruent to angle R. C is congruent to angle S. And then D is congruent to angle T. So notice I add an arc each time. Not because like T and Q can't be congruent, but we weren't told they were congruent, and so we always assume they're different. And so you can match those up like that, and then you can write congruent statements for both your angles and your sides. And so A is congruent to angle Q, and so on and so forth. So go ahead and finish those out. Okay, your sides are going to work the same way. So we can see here BC and SR are congruent just by looking at this figure. You can see up here BC and RS are located in the same positions in the name of their figures. And so you can kind of just work around that way. AB is congruent to QR. AD is congruent to QT. Right, remember, order of these doesn't really matter. So if you want to go up here, A, B, Q, R, A, D, Q, T, if you want to go in the same order, you can. Excuse me. Let's see, I did. So I need BC is congruent to SR. And then DC is congruent to TS. Okay, so you work your way around the triangle and identify those congruent parts. The reason that is important is because once we know the parts that are congruent, we are able to then set certain parts of that equation equal to each other. Okay, so here's an example of that. We're solving for both x and y. All right, we can see here that A and F are the same. So like if this is 80, this would be 80. Okay. If D is 44, then K is 44. So we know right now that 4x plus 2y equals 44. Well, because that has two variables, that doesn't really help us yet. So we go back up here and look at the sides. So GF and BA, GF, BA are congruent, which means that we also know that 3x minus 6 is equal to 9. So using inverse operations, we can solve that out, adding 6 to both sides and then dividing by 3. So we know that x is 5. Well, we can then use our substitution property to say, okay, well, 4 times 5 plus 2y equals 144. And we can solve that then the rest of the way out. Come up here. By subtracting 20 and dividing by 2. Okay, so now we have our y and we have our x. Okay, all because we knew that this was equal to this and this is equal to this. So we have those things that, because we know they're congruent, we can then set them equal. Okay, so I want you to go ahead and pause the video and try example 2. Using the given info, draw and label a picture, so a triangle this time instead of a polygon, and write all of your corresponding parts that are congruent. So you have angles and sides. You're going to have 3 of each, right? And draw your 2 triangles that are congruent. Label those respectively. Okay, so here's your answers. I have 2 triangles. Your triangles could look different than that. As long as they're labeled correctly, it's fine. And then I've put my corresponding parts, and I've set those congruent. So you can see Q and T are in the same position. I want you to recognize that even if TUV was flipped around, all right, we would still have to match it up correctly. So if this was TUV, sorry, am I using my V's look a little alike? Then we would still need to make sure that these angles and sides are matched up correctly. Okay, so a couple properties that we go through that help us with these. So properties of congruent triangles. No new words here. We have our reflexive, symmetric, transitive. And this just helps us set up the problems. Okay, so triangle ABC is congruent to triangle ABC. Your reflexive property, where something is congruent or equal to itself. Symmetric property, if triangle GDB is congruent to triangle QRS, then the converse of that is true. Triangle QRS is congruent to triangle GDB. Transitive, I'm going to pause that and write this out. All right, if triangle XYZ is congruent to triangle CUP and CUP is congruent to PRS, then XYZ is congruent to PRS, so your transitive property. So not new properties, just now using them with triangles instead of numbers or angles or whatever we used them for. And then last is your third angles theorem, and this is really the foundation for how we set up all of our problems in this section. Okay, so this states if 2 pairs of corresponding angles are congruent in 2 triangles that you're looking at, then the third corresponding angle is also congruent. So all that means is if you have 2 triangles and this one is 55 and this one is 80, and then over here this is 55 and this is 80, then that automatically means that whatever this angle measure is, this one is also the same. Okay, and that, if you think about your triangle sum theorem, which says that all of these have to be 180, that should just kind of follow logically from that, because so far they add to the same amount. So using that, you can then again set 2 things equal to solve for a variable. You could find a missing measure knowing that they all 3 add to 180. So that is kind of the foundation for how we set up these problems. Okay, so you will have an assignment tomorrow applying this and working out some problems using those corresponding parts. Remember, corresponding, that word is the same as before. It's in the same spot on its respective triangle. So it doesn't matter which way we face these. you can rotate them or flip them or whatever. They'll have a corresponding angle that they are congruent to. All right, have a good night.